Okay, so today we're going to be looking at something called the distributive law. The distributive law, as you can see here, is what occurs when a polynomial is multiplied by a constant. And the word multiply there is an important word because it distinguishes something new that we're doing compared to what we've been doing before. Previous to this, in the last lesson, we learned how to collect like terms. And just to remind you what that looks like, you don't have to write this part down. But if you look on the right-hand side of the screen here, to collect like terms, what you're doing is you're summarizing how many of each you have. So if you take a look at this one, 3x minus 4y plus 2x minus 7y, you're going to identify that the x terms are the same. 3x plus 2x, if you add those up, you get 5x. Negative 4y minus 7y is negative 11y. That's right, why we're writing subtract 11y. And what you're doing here in terms of math operations is you're doing adding and subtracting. So collecting like terms is an adding and subtracting sort of step. Today what we're doing, if you look at the example, negative 5 times 2x minus 5y plus 9, now you don't see a multiplication sign here, but because there's nothing in between the negative 5 and the brackets, it's assumed that that's a times sign. So I'm going to write that in, but then I'm going to take it out so it doesn't look like an x. But the idea here is that this negative 5 is multiplying with that polynomial. So everything inside that polynomial should be negative 5 times as big as it is now. What we're going to be doing is we're going to be distributing a negative 5, which means that all of the terms inside the brackets is going to be multiplied by negative 5. And if you remember what we know about terms, they're separated by plus and minus signs. So one term here is 2x, the next term is 5y, and the last term is 9. Those are your three terms. Just to give you an idea of what distribution means, you can see the little picture at the bottom here. Distribution is a word that makes sense in English. If I were to distribute apples to everyone in the room here today, what I'd do is I would give everyone an apple, right? This student would get an apple, this student would get an apple, this one would, this one would. I don't have all 30 of you up here, but you get the idea. So distribution means that every person gets one of those objects. Same thing with numbers. If I distribute a negative 5, that means that each term gets a negative 5. So negative 5 is going to multiply with 2x, negative 5 is going to multiply with 5y, and negative 5 is going to multiply with 9. That's what distribution means. After we have distributed the constant to all of the terms, what we say is that the expression has been expanded. So if you're given a question like this, your instruction often will be to expand. That means you're taking the number in front and you're multiplying it with all of the things inside. If you need to pause the presentation at this moment to write this step down, you can do so. Otherwise, if you're ready to move on, let's take a look at the first example. Oh, before we do actually, sorry, I forgot to remind you that a constant is just a number by itself. So there's no variable in there. We're going to focus on distributing with a constant first, and then once we're good at that, we're going to learn how to distribute with a variable in front. But right now, the thing in front is always going to be a number. Okay, so if we take a look at our first set of examples here, we'll just make this bigger again. There we go. So you can see in each of our examples there's a number in front of the brackets. In example A, the number in front of the brackets is 3. In example B, the number in front of the brackets is negative 2. That's the constant that distributes in. And in example C, it doesn't appear that there's a number in front of the brackets, but as you guys know, if you don't see a number there, the assumed number is 1. So that's actually a negative 1 that's in front of the brackets. If we take a look at the first example, that 3 is going to distribute to both terms inside. So first you're going to have 3 times 2a, and then you're going to have 3 times negative 4. This is what your writing is going to look like to describe what's happening there. So if you're doing 3 times 2a, you can show 3 brackets 2a to show that they're multiplying. The subtraction sign in between these guys is going to stay there, and then you're going to have 3 times 4. So the idea is that you used to be subtracting 4, but now it should be 3 times as big, so that answer is going to be 3 times 4, or 12. Once you simplify that, once you clean that up, you have 3 times 2, which gives you 6, and 3 times 4, which gives you 12. In this question, you're finished because 6a and 12 can't be collected together. They're not like terms, right? A is a variable term, and 12 is a constant term, so you've expanded it, and now you're finished that question. If we take a look at the next one, you have a negative 2 that's distributing to everything inside. And the fact that that's a negative 2 does make this a little more difficult. If you're distributing in a negative 2, you're going to have some sign issues going on. I'm going to take a second to show you, like in detail, what's happening with the signs, and then show you sort of a shorter way to write it. So if you think about keeping the signs that are there and multiplying them by negative 2, this is what your step is going to look like. So I'll show you the whole thing, and then I'll show you where this stuff comes from. So you can see I've got a -2 in front of each term that shows that it's multiplying, and I'm basically keeping what was there. So for the first one, I've got -2 times 3y, which was the original. Then I have that subtraction sign staying, and then I have -2 times 4z, that's that term. Then I've got the plus sign staying, and I have -2 times 6. Now, what's happening here is a little awkward because I've got a lot of pluses and minuses all over the place. But as you can see, these two negatives, double negative, is going to become a plus. And this plus negative, this plus minus, is going to become a subtraction sign. So then based on that, you could have actually written the original question something like this. So if you take a look here, I've got the same numbers. I've got 2 times 3y, I've got 2 times 4z, and I've got 2 times 6. But I'm thinking about the signs separately than the numbers. So for the first one, you've got, if you look at the top here, you've got -2 times +3. Negative times positive is negative, so that's why I have a negative sign down there at the bottom. For the next one, I've got -2. Maybe I can just move that dot. -2. Try that again. There we go. I've got -2 times -4. Negative times negative is a positive, and that's why at the bottom here there's a plus sign. For the last one, you've got -2 times +6. Negative times positive is negative, and that's why I have a subtraction sign in between those. So the idea is that you can think about the signs separately from the numbers, and that makes it a little easier. Once you've done that, you can just multiply the numbers together. 2 times 3 gives you 6, so that's -6y. 2 times 4 gives you 8, so that's 8z, and 2 times 6 gives you 12. Now, I'm thinking that a lot of you are probably deciding that this much writing isn't particularly necessary for you. Maybe you're looking at the top there and you're thinking, I can do -2 times 3 and get -6. I can think about -2 times -4 and know that that's +8, and I can think about -2 times 6 and show that it's -12. And in fact, the only step you have to show for this is this one at the end. You're probably going to want this one here for a little while until you know what you're doing, but you are allowed to skip that step and just show this one at the end. Similarly with this question over here, I will allow you just to show that one, because eventually that's where you're going to be. So show the first step for as long as you need to until you feel you understand it, and then you can start skipping it, and that's fine. If you take a look at the last example, you've got a -1 in front of the brackets. So that means that all of the terms are going to be multiplied by a -1. That's the number that's distributing to all of them. There's a -1, invisible -1 there, and if you take a look at the terms, there's an invisible 1 somewhere else. If you take a look, you should be thinking that that number is in front of the x. Okay, so there's an invisible 1 in front of there as well, and because we're thinking about multiplying coefficients, it's important to think about what's actually there. Now, in terms of multiplying, I want you to think about the signs separate from the numbers. So take a second to think about just the signs. So negative times positive, your first one's going to be negative. Then if we take a look at the next one, negative times positive is going to give you negative, and for the last one, can I grab the dot? Maybe not. For the last one, negative times negative is going to give you positive. Based on that then, here's what you're going to have. Okay, so those red plus and minuses were what I just talked about, and then you just have the numbers multiplying. So you've got 1 times 4x squared, 1 times 1x, and 1 times 7. The signs are important. Make sure you understand where they come from. Negative times positive for the first one gives you negative. Then for the second one, negative times positive gives you negative. And for the third one, negative times negative gives you positive. From here, all you have to do is multiply, which is easy to do, because multiplying by 1 is not that tricky. The numbers don't change. So you're left with negative 4x squared minus 1x plus 7. Now, technically, this question is finished, but it has something extra that we don't really want. The best possible answer is at the end then to drop out that invisible coefficient of 1. And as I said here, the best answer is going to drop the invisible 1 at the end. So there's going to be times when you're going to have to show those 1s, just like when we did power laws, we had to show 1s sometimes to think about what we were doing. But then at the end, they're not really necessary to say, so the nicest answer doesn't have them in there. I'm going to stop this part of the lesson here. There are fraction examples yet to come, but I'll leave them for the second half.